Hi everyone, this is the first video for section 2.5 absolute value functions. The first thing that we're going to do is go ahead and make a comparison between the identity function and the absolute value function. So one of the first things that I want to note here is that if we were to take the left half of the x-axis and use it as a line of reflection, we would actually be able to create the image of the absolute value function. So let's go ahead and reflect basically the bottom left portion of the identity function and connect those dots, and then I'm going to just try to overlay it here. So we've actually created the absolute value function right here. And what I want you to note here is that there is a difference between what the identity function is describing to you and what the absolute value function is describing to you. So to begin, the identity function, we can kind of talk about it very literally and say, if we use a positive x value, our output, or our y value, is positive. Think of it as moving forward. However, if we use a negative x value, our output or y value is also negative. Think of it as moving backward. But we have a very interesting situation when we turn our focus to the absolute value function. What do you know about the outputs every time you put in anything for your input, whether it's positive, negative, or zero? And hopefully what you're saying is, well, I get a positive number out no matter what. This is because the absolute value function measures distance from zero. And basically one of the major points that you need to take away from studying the absolute value is that distance can never be negative. Okay, so again, let's kind of highlight that or box it. Okay, never be negative. Okay, so let's again explore this a little bit further. We can rewrite the absolute value function into a piecewise function, and it will have two pieces. We would say that one piece is negative x if the x values that we are inputting into the function are less than 0. Our other piece is that it's just going to be x or positive x if x is greater than or equal to 0. To demo this, give myself a little bit more space. Say we want to use x is equal to negative 4. So that means that if we do f of negative 4, I'm going to have to refer to this first piece here, because negative 4 is less than 0. So if I do this, then I would have negative 4 happening, which would result in a positive 4. Bear in mind that if you did this using the actual function, the absolute value of negative 4 also gives you positive 4. We can make a similar comparison if we did something like x is equal to positive 9. F of positive 9 would take us to this bottom piece because 9 is greater than or equal to 0. So this would result in just positive 9. And again, if we had used just the absolute value function as we know it, it would also result in a positive 9. So what I want you to take away from this is that the piecewise function is just a rewrite or a different definition or a redefining of the function that we pretty much all know, love, and are used to. Okay, so you're ready to move on to video 2.